Dear students, I welcome you for the today's lecture related to the vessel and its design considerations. Now, generally the process engineers who is going to specify the needed or the required parameters for operating the vessel at the desired temperature, pressure, concentration conditions. So this process engineer, he defines all the basic needs, and accordingly one has to design a vessel which will be providing or which will be suitable for giving the desired product. So these designing parameters that is to be considered before detailed designing of any equipment. So these different parameters which can be taken as the vessel functioning, the selection of the parts and the other accessories which will be depending on the vessel functioning, which are the different internal parts associated with that vessel that is dependent on the vessel functioning. For a reactor, you require an agitator. For a heat exchanger, you require the tubes and the tube bundle. For a distillation column, you will be requiring either packing or the trays. So depending on the function, the accessories of that particular vessel are going to vary. Then the process material. The process material, which is nothing but the material which is being processed. Material which is being processed. That is our process material. And based on this process material, operating temperature, pressure, and the quantity, based on the temperature, pressure, and the quantity of the processed material, you are going to decide the capacity of processing. You are deciding the material of construction. You are going to decide the stresses based on the material of construction. So all these different parameters, that is based on the process material, the material which is getting processed. Then the capacity for processing, this much amount of the fluid that is to be processed to produce this much amount of the desired product. Then the type of the service, then location, is it located inside the building or outside the building, then the shape and the geometry, whether it's a cylindrical shape, circular a hemispherical shape, or a square, or you can say the cubical shape. Then the orientation of the vessel, whether the vessel is vertical or horizontally oriented or vertically or horizontally operated, again depends on the functioning of the vessel. Then the operating temperature and the pressure, that is related to your process material temperature and pressure. Based on the above parameters, we are going to select a material of construction for a vessel. Material of construction for a vessel. Then that vessel sheets are to be used, and these are welded to give the desired shape, whether it's a spherical, whether it's a cubical, or whether it's a cylindrical. Then the corrosion allowance has to be added based on the process material and the material of construction. we are considering the corrosion allowance. This process material which is going to corrode the material of construction which is selected for that vessel. Then the calculated thickness has to be calculated. Then based on this thickness calculation, by considering the different loads, we have to consider the different loads to calculate the thickness. So which are the different loads? That will be, we are going to understand. We are then comparing the calculated thickness with the allowed stresses of the material of construction, then the different methods of the fabrication or fabrication techniques which are needed, then how much service life, whether it is 10 years, 20 years, 50 years or 100 years service life, what is expected. But generally 20 to 50 years of service life is considered, because the innovations and new products, and you can say the outdatation of the products that may arise if it is for a very long service life, and the finally the economic aspects, they are to be studied. So all these are my vessel design considerations. While designing a vessel, I have to consider all these different parameters. These are the limited which we are going to discuss. In addition to that, there are a lot many parameters that can also be considered. And when you go into the detailed designing of the vessel, then you have to consider much more details. So vessel functioning, whether it's a reactor, heat exchanger, distillation column, absorber, liquid separator or liquid entrainment, all these are your vessel functioning. And based on this vessel functioning, I have to attach the other accessories to that. And these other, the basic needed accessories with, to any vessel is your heads, flanges, nozzles, gaskets, then supports, then pipelines, and some instrumentations. So these are my basic design components which are needed for any vessel. Now, in addition to that, depending on the functioning of the vessel, I can go on adding the number of internals. Those internals can be sparger, then the baffles, then types of the baffles, then draft tube requirement, then you may require certain agitators. In case of a heat exchangers, you may require the tubes, tube sheet, baffles, then tie rods. Then in case of a distillation column, you may be requiring the trays, distributors, support, then weir, downcomer, all these different attachments or accessories that is to be taken into account while selecting the other parts and the accessories. Then the process material, which is the most important, and based on this process material, we are going to select the various different parts, various different material of construction. Then the material which is being processed in the equipment is your process fluid, process material. This type of the fluid which is handled or being processed, that can be of in different phases, whether it's a gas phase, liquid phase or solid phase. Again, depending on the gas, liquid or solid phases, your material properties may vary sometimes, or only if it is a solid, then the handling of that is essentially to be understood. Then physical and chemical properties, they are also to be studied. Also the special properties while constructing the equipment has to be taken into consideration. Then based on this process fluid, process material, how much amount that is to be processed is depending on this process fluid. So necessary volume that is to be calculated. So itne volume I am going to use for the fabrication होने के बाद में this much amount of the fluid that will be processed, and his volume, based on the volume I'm going to have the cost based on this volume only. I'm going to have the operate capacity based on this volume of the vessels. Vessel volume is very much essential. एक कुछ तो vessel volume है, based on that only I am having the limitations related to the product or the production capacity, quality of the product, that also, as well as the quantity of the product, that is also based on this capacity. Then the vessel size is decided by the mass transfer, heat transfer, and the kinetic aspects. The chemical reaction engineering is basically involving the kinetic aspects in addition to your mass and heat transfer fundamentals. So one has to decide this volume based on all these kinetic aspects. And uh, once this volume that is decided, then and only then the fabrication details that can be studied or can be taken into the considerations. Then they calculate the dimensions of that vessel, that is the length and the diameter of that vessel will be decided based on the availability of the different accessories which will be attached to that vessel. Then the calculate the length L by DO, and the DO by T is your thickness ratio. You require certain thickness, based on that you define certain parameters. Then the geometry of a vessel and the type of vessel required for process which can be fabricated economically for that process requirement. So fabrication details, that is also needed. Then the type of service, whether it's a semi batch, whether it's a continuous process, whether it's a intermittent or process or a fluctuating process, or sometimes it can be a seasonal process also. Corona आ गया, you are going to produce the remdesivir and the fabiflu, which is very much needed. So again it becomes your seasonal product. Seasonally, I have to increase its capacity to a drastic rate. Then the manual or controlled by the advanced controller systems, that is also to be taken into consideration. So all these are our vessel design consideration. Vessel fabricate करने का है तो मेरे को कौन कौन से conditions, कौन कौन से points सोचने पड़ेंगे. That is what we are studying. All this is what is planning, and that is what we are trying to manage the things by basic understanding of the subjects of our heat transfer, mass transfer, and CRE. So we are planning for a better suitable vessel, best suitable vessel we are trying to build it. Then the location of the vessel inside the plant, whether it's inside or outside the building, or whether it is suitable located on the ground or on some second, third floor, all that is to be taken into considerations. If it is on the ground, then which type of the support. If it is on the second floor, then which type of the supports. All these are the different considerations based on the location that will be taken into account. Then the shape or the geometry of the vessel, whether it's a cylindrical, spherical, conical, square, or rectangular shape, that is to be taken into account. Then the vessel orientation, whether it's a vertically oriented or horizontally oriented, that is also to be taken into account. Then the operating temperature and pressure. So design temperature, the strength of material decreases with the increase in the temperature. So the maximum allowable stresses will depend on the process material or the operating temperature. And this is the operating temperature, whether it's a higher operating temperature of a material, or sometimes you have to take the minimum design metal temperature also. So minimum design metal temperature should be taken as the lowest temperature expected in the service. Now, if it is in India, then if it is in Nagpur, then our lowest temperature is not more than 5 degrees Celsius on an average, and the highest temperature may go up to the 47, 49 or say 50 degrees Celsius. So in this temperature range of 5 degrees Celsius to 50 degrees Celsius, but if it is say in Canada, which is very cold country, where it goes to the minus 40, minus 60 degrees Celsius sometimes, then this minimum design temperature, that has to be also given the proper importance for minimum design temperature. Maybe the operating temperature in India as well as in Canada, that will be same, because it is the requirement of the kinetics. But the minimum design temperature, that is going to vary from location, geographical location in India and in Canada. So 5 degrees Celsius to minus 50 degrees Celsius, that is what a wide change of temperature is there. So one has to consider the minimum design metal temperature also. Then design pressure, which is suitable to withstand the maximum pressure. Then material of construction, the availability of different material of construction and their cost data, that is to be considered. All this is related to the cost. So suitability of a fabrication of a material of construction, which will be giving me the good service life with minimum corrosion, that is to be selected. So selecting the material of the equipment according to the technical parameters, which is decided by the process engineer. By considering the process fluid, corrosive nature, the operating and the design temperatures, the pressure, length of service, material stability in the environment, all these parameters that is to be taken into consideration. Then the allowable stresses of the material. This is related to the material of construction. Vessel जिस मटेरियल से बना हुआ है, उसकी allowable stresses has to be taken into consideration. Now here generally the students, they get confused related to which material. The process material is different and material of construction is different. One has to remember this thing. The material of construction is having the allowable stresses of material. We are talking about the stresses, strain, tensile stress, tensile strength. All these are related to the material of construction. जिस मेटल से और जिस मटेरियल से वो वेसल फैब्रिकेट हुआ है, that is to be taken into consideration. And the process fluid, process material, based on process material I have to select the material of construction, and material of construction, there I need the stresses requirement. Then the plain carbon steel, low alloy and high alloy steel, different types of alloys, sometimes the reinforced plastics, they are generally used as the material of construction for the vessels. So these pressure vessels, based on certain design codes and standards which are accepted by the different countries, they are to be followed for fabrication of a vessel. Then once the material of construction is decided, then one has to fabricate a vessel. For fabrication, you require to do the welding. So welding, which type of the welding, what skill, which skilled worker is doing that welding, or whether it's a robotic welding. Now, even though the advancements of related to the robotics is there, but only very few companies which are producing the huge volumes to a larger scale, they are only using the robotic arms, and the maximum is dependent on the actual welding of our chemical equipments, because it's not defined कि यही वॉल्यूम चाहिए, only this much has to be fabricated. If you talk related to the car manufacturing, the designs are same, where I can implement robotics, but I cannot implement in our chemical equipments because they are going to vary continuously. It is not fixed dimensions, and that is why we require the manual welding in all these cases, and it's the skill of a person who is doing the welding, and depending on that, the joint efficiency which is taken into consideration. If it's a class A vessel, then the joint efficiency J, which is taken as a 1, a very good quality of welding that is taken into account. Similarly, for class B, J is equal to 0.85. For class C, J is equal to 0.7 or 0.5. Now, what is to be done for the joint efficiency? The allowable or maximum permissible stresses of the material multiplied by the joint efficiency means the maximum strength. What is the allowable permissible stresses of that material for that temperature range मल्टीप्लाइड बाय जॉइंट एफिशिएंसी, उतने जॉइंट एफिशिएंसी से कम हो रही है वो maximum permissible stresses of that material. Now, how to check this welded joints? You require a visual inspection and the non-destructive testings that is to be carried out. Generally, nowadays the ultrasound technique, which are the most commonly used in our chemical industries, but previously it was radiographic technique which was the common, and dye penetration test, hydraulic test, pneumatic test, then the eddy current test, magnetic particle test, and the freon test. All these different tests, they are to be carried out for the visual as well as the non-destructive testing. And when doing the testing, one is able to determine the wall thickness, then the डिटेक्शन ऑफ द सरफेस फ्लॉज, जो कुछ वेल्डिंग सरफेस है उस वेल्डिंग सरफेस पे कुछ क्रैक्स, अनइवननेस, यूनिफॉर्मिटीज, these flaws, they can be detected. Then whether it's a continuous or discontinuous material, certain cracks are there. If the cracks are there, then material gets discontinuity. Then the internal flaws in the vessel wall, that can be also detected. Then the corrosion allowance that is to be added, it is the additional thickness of a metal which is taken into consideration while designing. So generally we are adding the 2 millimeter thickness, 2 millimeter metal thickness, that is to be added for the design purpose in addition with the theoretical requirement. So we are adding the 2 millimeter thickness in calculation of the total thickness. Because it's a complex phenomena, it is not a definite or rules which are being followed for that. And for that, generally this 2 millimeter thickness is to be added. And sometimes if the conditions are severe, then the 4 millimeter thickness that can be also added. Now the calculation of the vessel thickness, you require the pressure, diameter of the vessel, the stresses of the material, J the joint efficiency, and the corrosion allowance, C. So generally it is the 5 millimeter thickness that is to be used, even if the vessel diameter is less than 1 millimeter or up to 1 millimeter. Now, if the vessel thickness that comes say 3 millimeter by this formula, then I am not going to use the 3 millimeter thickness, but I am going to use the 5 millimeter thickness. Because of the welding problems, generally the lower thickness material, they are not properly welded, and that is why for getting the good quality welding, we are using the 5 millimeter metal thickness. Then the design load, which is the most important part. The structure must be designed to resist the gross plastic deformation. Now here one has to remember the basic stress versus strain graph, which is needed to understand all these parameters. This is the stress is directly proportional to the strain. Then it reaches to a maximum value. Then it comes back and then it will break after certain time. So this is the stress versus strain. Stress is directly proportional to the strain, and here you can regain the original properties. But if it is crossing this maxima, that is the maximum elastic limit, it goes into the plastic deformation, where this plastic region you cannot able to attain the original values of the stress and strain. So after application of specific amount of the stress, it goes into the plastic deformation. And it has to plastic deformation. The structure must be designed to resist the gross plastic deformation and collapse under the conditions of loading. So material should be able to regain its original properties. So it should not go beyond this elastic limit. Then the different major loads that is to be taken into account, and the different subsidiary loads that is also to be taken into account. Now when you talk related to the major load, that must be the considered the vessel designing. One is your design pressure, which is the most important and the basic parameter. When we talk related to the thickness formula, thickness which is equal to the PD upon pressure. Pressure, it's a design pressure that is to be taken into account. So includes the any significant static head of the liquid also. Then the maximum weight of the vessel under the operating conditions and or the hydraulic conditions. Now this maximum weight that will also incorporate the weight of the heads, flanges, nozzles, gaskets, supports, different pipe attachments and different instruments. All these are to be taken into considering while calculating the maximum weight of the vessel. And the weight of the contents also that is to be added, because that is also going to be there by the operation. Now if it's a gas, then the weight of the content is comparatively less, or if it's a liquid or say mercury which is having a very high density, then the contents of the weight is 13.6 times than the weight of the water. So that is also to be taken into account, that is the contents. Then the hydraulic tests, if it's a gas, then the density is very low, but we are doing the hydraulic testing with the water generally. So that is to be taken into account. Then in addition to that, the vessel which is exposed to the atmosphere or to the surrounding, where the wind that is also acting, if it's a tall vessel, then this wind load becomes the important parameters which is to be considered in designing, like our distillation columns, absorption columns, stack, that is your chimney. All this is to be given the prior importance of this wind load. If the vessel diameters are 1 or 2 meter, then your wind load that becomes a negligible part. But for tall vessels and areas where the high wind loads are there, then one has to take this wind load designing parameter has to be taken seriously. Then the earthquake, that is your seismic load, which is to be considered depending on the earthquake prone area. Then the load supported by reacting on the vessels. So, and the subsidiary loads, these are our important loads. Now coming to the subsidiary loads, that is the local stresses caused by the support, internal structures and the connecting pipes. Now say if it's a vessel, and to this vessel I am going to attach a certain pipe. So at this area, the different stresses that will be developed, and one has to take these small stresses also. Now to this mobile, I have cut this area, but we are providing this certain thickness here, and this certain thickness which will be helping as a reinforcement. ये एक्स्ट्रा दिया हुआ है इसको, but that is helping as a reinforcement material, because we have cut this section. When this section that is cut, it should not hamper the or loosen, reduce the stresses. So to maintain the stresses, we are adding this extra material here to increase the strength. So these local stresses caused by the support, internal structure and the piping systems. So these shock loads that is caused by the water hammering, then surging of the vessel contents at the time of maintenance. We are giving or hammering with something for opening the nuts and bolts. That is also a shock load. But this shock load applied is very small in comparison with the water hammering or steam hammering. स्टीम हैमरिंग में जबरदस्त प्रेशर डेवलप होता है, प्रेशर डिफरेंसेस के कारण वो हैमरिंग होता है. Then the bending moment caused by the eccentricity of the center of the working pressure relative to the neutral axis of the vessel. So bending moment, torsional moment that will be caused on the vessel. Uh, if it's a rotating shaft, then torsion that will come into the picture, and it's a bending movement that will be caused because of the different attachments which is going to form the non-uniformity in the balance of that vessel. Then the stresses due to the temperature difference and the differences in the coefficient of expansion of material. If there are two different materials, then this factor of coefficient of expansion because of the two different materials, that will become more and more serious. But generally it's a single material of construction that is used for vessel fabrications. Then the loads caused by the fluctuations in the temperature and pressure, then the vessel will not be subjected to all these loads simultaneously. This is important thing. These major load as well as these subsidiary loads, they will not be subjected at all times. This wind load or seismic load is a very rare case. It is not there always. Wind load, that again depends on the geographical condition. So wind load and seismic load and your this testing load, that is also the very intermittent or fluctuating. So the vessel will not be subjected to all these loads simultaneously, but the designer must determine what combinations of different possible loads gives the worst situation. एक समय में कितने सारे डिफरेंट लोड्स एक्ट हो सकते हैं पूरी से पूरी कंडीशन में, वो सिचुएशन एज्यूम करके मेरे को डिजाइनिंग करने का है. विंड भी एक्ट हो रहा है, अर्थक्वेक भी आ रहा है, एंड ऑल योर pressure fluctuations are there, so all things are disturbed. It is very rare situation. So designer must determine what combinations of possible loads gives the worst situation. Then the dead load, we are calling the dead load. Sometimes the terminologies may be different. That is the weight of the vessel plus weight of the internals plus the weight of the contents. Area on which the load that is acting, that is taken into consideration. Then the forces, that is wind load, earthquake, then reactions from the platform or from the supports, that is also there. Then allowable stresses and the yield stresses. The material of construction, for its allowable stresses has to be taken into consideration. We have talked the stress strain graph. Stress is directly proportional to the strain. Then it reaches to the maximum stress, which is nothing but your yield point or the yield stress. And after that it goes into the plastic region. So allowable stresses क्या है? जो कुछ yield stress है, maximum stress है, उससे ज्यादा exceed नहीं होने चाहिए. ये जो yield stress है, which is the maximum point, beyond that one should not go. One should not reach to this plastic region. Only our operation that will be restricted to this stress is directly proportional to the strain area. It should not go beyond this yield stress. Yield stress के बाद में material कब destroy हो सकता है, that is again a question mark. How much plastic limit it can have. Then calculate the resultant stresses according to the different failure theories. So one must know the different theories by which the stresses that can be taken into considerations. So allowable stresses, that different theories of failure we will be discussing in subsequent classes. Then compare that with the allowable stresses of the material. If the resultant stresses Resultant stresses are to be calculated based on the different loads. Resultant stresses that will be calculated based on the different loads. So these different loads, thickness, corrosion, इससे जो कुछ resultant stresses मिलेगी, that should be compared with this allowable stresses of the material. If the allowable stresses of the material are more than your this resultant stresses, then and only then that assumed thickness is finalized. So at what thickness I have to operate it? I have to fabricate that vessel. That is most important thing which is needed is the calculation of the thickness, which has to be compared with the resultant stresses and the allowable stresses, or you can say the permissible stresses, and they should not be exceeding the yield stresses. Your graph should be remaining in this stress strain region only. It should not exceed the yield stress region. It is determined by applying a suitable safety factor to the maximum stresses that the material could be expected to withstand without failure under the standard test conditions. So उसमें भी मेरे को सेफ्टी फैक्टर अप्लाई करने का है at that temperature and pressure conditions. So this factor of safety lambda, that is to be considered based on your yield stresses. The factor of safety allows for any uncertainty in the design method. डिजाइन मेथड में कुछ लैक्यूनास आ गए हैं, कुछ कंसिडरेशंस नहीं किए हुए हैं, एंड दे आर टू बी एडजस्टेड इन दिस फैक्टर ऑफ सेफ्टी. Any equipment is very important. Not only the equipment, but the human life is very much say important, and one should not be careless while designing all these factor, all these vessels, and it should be the zero accidents. Then the different fabrication techniques that we will be discussing in the details. Then what will be the expected service life, that is your durability, and assuming the certain usage for life, they say 10 years, 20 years, or 50 years, whatever the depending. If you talk related to the refineries, its service life is expected to be of 50 years and more than that also. But if it's a seasonal product, then consumer goods, then the probabilities may change. Then which can be fabricated economically for the process requirement. So all these are my basic requirements which are to be taken into considerations for the